In this video, we're going to have a look at how photons can be related and the energy changes can be related with wavelengths. So it's asking for the longest wavelength of the emitted radiation. Now, what's sort of happening here? Well, electrons in high energy levels, they can de-excite and lose energy in the process when doing so. Now, that energy that they lose, that doesn't just disappear. It actually escapes in the form of a photon. And this question is asking for the longest wavelength of the photon that can be produced. Now, some of you guys might think, okay, well, maybe if we use the longest path of de-excitation and the largest energy change, that would result in the largest wavelength. Actually, let's think about how energy relates to wavelength. So, combining E equals HF and frequency equals speed over wavelength, replacing frequency with speed over wavelength, we get E equals hc over wavelength. Since h and c are constants, that means that energy is inversely proportional to wavelength. So essentially, the longest wavelength correlates to the smallest energy change. So it's actually this first part of the excitation that I drew, which is the smallest energy change. So we can find the difference between these two energies. We can just do 2.29 take away 2. Oops, sorry, don't know what happened there. Sorry, that turned out very messy. 2.29 take away 2.06. And that would equal 0.23 times 1.2 10 to the minus 13. I just didn't multiply by 10 to the minus 13. I didn't really see a point there. And that's the sort of energy change that happens there. From there, we can relate it to this equation and we can make wavelength a subject. So we can multiply wavelength to that side and move energy where a wavelength is. And we get that lambda is equal to hc over energy. In this case, h is given in your equation sheet. That's 6.63 times 10 to the minus 34. C, we can assume that because it's gamma radiation, it's a photon, so it travels at the speed of light, so that's 3 times 10 to the power of 8, all divided by the energy in joules, which is already found here, so 0.23 multiplied by 10 to the minus 13. That would correlate to the longest wavelength that's produced. So I'm just going to very quickly find that. 6.63 times 10 to the minus 34, all multiplied by 3. By the way, if you guys do find this useful, I have a whole quantum physics playlist, so yeah, look out for that on my channel. And then all of that divided by 0.23 times 10 to the power of minus 13. That would give you a value of 8.65 times 10 to the minus 38. Hold on, I don't think it does. Sorry, I might have typed that in correctly. Okay, so 3 times 10 to the 8. Because I actually need to remove my division sign. Yeah, that's a much better answer. 8.65 times 10 to the minus 12. And because it's a wavelength, it's essentially a length that you're measuring, so it's in meters. Perfect, that's everything for this question. Be sure to leave a like if this video did help and subscribe, I'd appreciate a lot. Feel free to share the video too if it helped.